In this lesson, we're going to learn how we can start to create soft body effects within RealFlow. Okay, so for this particular example, I'm just going to start with a blank scene. So let's go ahead and get a very quick little example set up here. So we'll start with just a basic plane. This will be our floor. And let's go ahead and go up to our primitives list, and let's go to import. So if we take a look inside our lesson 14 start, inside the objects directory, we should have this SD file in here called soft body cubes. So go ahead and bring that in. And essentially this is just a couple of cubes that have been stretched out. And we'll come in and try to make these look kind of like a soft little floppy piece of plastic or rubber, something like that. Now if we want, we can come in and just take this camera, remove that, since we really don't need to have that in there. And to go ahead and set this to a shaded view, I'll go ahead and press the 0 key on my keyboard. Okay, so we have our objects in here. Now, just like what we had to do with our rigid bodies, we need to come in here and make sure that we have something like gravity so we can actually have something to pull these objects down. So now, let's take these three objects with all three of those selected. Let's go up to our node parameters, and underneath our dynamics, where default this is set to no, let's go ahead and set this to soft body. Okay, now at this point, we just press the A key on our keyboard to simulate, and let this go through. So you can see right now our soft bodies are going to be falling through the floor, which is completely normal. So what we have to do, again, just like what we had to do with our rigid bodies, take our floor object and make sure that it's set to a passive rigid body. There we go. Let's go ahead and now press the A key once again and let this simulate for just a moment. Okay, and once we've let that go through for a few frames, we'll go ahead and just play through this or scrub through this. And what we should see is these objects start to fall, and you can see they actually start to deform and sort of fold in on each other. So we may get these warning messages saying that some of these objects may be under-tessellated. That's okay. Really, these are some fairly low-resolution objects, and these will work just fine for visualization purposes. This is really just more of a warning that something may possibly go wrong, not really a warning that something is wrong. So when it comes to actually working with these soft bodies, we do have several attributes that we can start to get in here and control. So if I were to grab this top cube and go to the soft body tab, you can see that we do have things like mass, which again pretty much just controls the overall weight of this object, how heavy it is. Now below that we have our resolution. This is very similar to our fluid particle resolution, where this is really just controlling the overall accuracy of our simulation. So higher resolution is going to give you some more realistic, more accurate results, but your simulation times may also start to increase as you begin increasing this value. Now below this we have our length stiffness. Now the length stiffness you can really think of as really just the overall flexibility of this object. So with a lower stiffness, you're going to find that your objects are going to be much more prone to bending and flexing. So if I were to take this from the default value of 0.4 to something quite a bit lower, like maybe 0.1, and go ahead and press Ctrl A on my keyboard to reset my simulation, and A to resimulate. And we can start to see that once the simulation goes through for a few frames, that we start to play this back, that we start to see now quite a bit more flexibility in this top cube here. So it's really flexing and really bending. And again, we can continue to bring this down, maybe to some even lower values. I'll try something like 0.05. And again, reset my simulation. Okay. And then, again, playing that back, we should see now even more flexibility and more bending that happens in this topmost cube. Now, just to make this a little bit easier to see, what I might do is just very quickly come in and maybe set the color for these different guys here. Maybe make some of these look a little bit different, just so that they're not all the exact same color. There we go. Hopefully that'll make things a little bit easier for you to see. All right, so again, with this, we have just looked at our length stiffness. Now below this, we have our volume stiffness. Now, these two really kind of work hand in hand, but at the same time, they still do a different effect at the end of the day. So your length stiffness, again, think of that as just your overall flexibility, or the amount of bend or flexibility that your object has. Whereas the volume stiffness is really this object's tendency to retain its original volume. Think of it sort of as the compressibility of this object. So if I were to take my volume stiffness and begin lowering this, we should see that overall this starts to become much more soft and much more squishy in its appearance. All right, and then once we let this simulate through for a few frames, if we were to again go back and look at this, you can see now the overall volume of this really starts to compress and squish. So as opposed to something where we start to increase this volume stiffness, we're going to start to see something that looks like it really has a solid internal volume, something that is not hollow on the inside. Whereas by bringing this stiffness down, we start to see something that really looks a little bit more like maybe an inflated object, something that maybe has no real true internal structure. So really, again, just lots and lots of control that we have over this. We also have the elasticity. Now, elasticity is very closely tied in to this other attribute, the internal dampening. So really think of these two as being two parts of kind of the same equation. So elasticity is this object's tendency to bounce. So it's really controlling how much energy gets retained in this object and how much wobbliness and kind of some of these tremors that we start to get within this object. So this is controlling how much energy we have, whereas the internal dampening controls how quickly that energy gets dissipated. So if I were to come in here and maybe bump up this volume stiffness just a little bit more, take that back up to maybe something like 0.8, so that way we don't have quite as much of this wobbliness to begin with. And now maybe start to take this elasticity and start to bring this up. So again, maybe something like 0.8, just to see what that looks like. Again, reset my simulation and let this go through for a few frames. Okay, and once we have that in place, go ahead and maybe just pull my camera back. And now you can see that as we start to scrub through this, you can see now we have a lot more of this jiggle, a lot more of this wobbliness in our shape. So again, that's something that's controlled by this elasticity. Now, if we wanted this jiggly effect to really be that prominent, but maybe we wanted that to die off a little bit more quickly, have that jiggle maybe not last quite so long, that's where this internal dampening starts to come in. Okay, and then another really nice thing that we have with this, if we scroll all the way down to the bottom, we actually have the ability to plug in a high-res object. So if we had maybe a high-resolution and a low-resolution version of this same object, what we could actually do is do all of our soft body calculations and simulations on this low-resolution version, and then have RealFlow feed all that deformation data over to the high-res object, instead of having to dedicate the time and the resources to actually do the soft body simulation on the fully high-resolution object. So when it comes to working with these soft bodies, these are something that can actually interact with other rigid body objects. They can actually start to interact with fluids as well. If you'd like to see a little bit more of a practical example of where we could actually use some of these rigid bodies, or rather some of these soft bodies, this is something that we actually do cover as part of our course titled Pipeline Integration with Maya and RealFlow. So we actually learn how we can start to use some of these soft bodies for practical purposes. So for now, that's a quick look at how we can start to integrate these soft body effects into our RealFlow simulations.